Hi folks, it's been a minute since I've been on YouTube, and in that time I managed to sell, give away, donate, and throw out a bunch of stuff. And yet somehow I still have a bunch of stuff. It had really gotten out of hand, and I would like to move at some point and get out of Florida. But in the meantime, I am currently not working right now. My employer is on strike, or the union is on strike against my employer, more correctly. So I have a little more time on my hands. I am getting some more of the backlog done. And one of those pieces belongs to my friend, and probably yours by now, Steve. He had brought me a Pioneer SX-950, and he said that it would act properly on the dim bulb, but then would start to pulsate. So let's take a look at it, see what it's doing, and see if we can find out what the problem is. Okay, so the story as I got it is my friend Steve got this SX-950 for a really good price, and he looked in a picture when the cover was off and saw that the bias diode had broken. Now, I haven't been into this thing and I'm not that familiar with them, but usually they mount the bias diode excuse me, on the heat sink, or even sometimes on one of the driver transistors. Unfortunately, even though it was professionally packed by one of the shippers, the glass got broken. So he's got a spare glass, but currently it doesn't have any. And he told me he had a replacement bias diode, and since they're usually mounted on the heatsink, a lot of times they get broken during disassembly. You have to be really careful about that. And he put the replacement in. He said now when he cranks it up on the dim bulb, it starts bright, dims down, and then pulsates. So we're going to start it up in the dim bulb and see what we get. Okay, so I got it plugged in the dim bulb tester, got a 100-watt bulb in here, and let's see what we get. Bright and dim. That actually looks good, but I don't hear the protection relay click. So we're going to have to take the cover and bottom off and see what we need to get to figure out what's going on. Okay, so really I didn't have to take the bottom off to get to what I need to get to in order to start making a diagnosis. We have all our pins here that are notated on the schematic, and they're numbered. I'll take a closer picture so you can see what I'm talking about. Then we're going to look at the schematic. These are the bias diodes that I talked about, and you can see how you could rip them off if you weren't paying attention during disassembly. And apparently that's what happened. I don't know which one my friend replaced, but we're going to take some voltage checks and see what we could find here. But before I do that, before I put the schematic up here, I just want to talk a little bit about the bias diodes and what their function are. If you look here on the schematic, you can see they just look like a bunch of diodes stacked up together, and indeed that's basically what they are. However, the important thing with these is the curve, or the temperature coefficient. They have to closely track the heatsink and make the appropriate changes to the bias circuit so that the bias doesn't run away. If your bias becomes too high, you can go into a state known as thermal runaway, where the bias just keeps increasing until the output devices self-destruct. So even though they look like just a few diodes stacked together, they're a little more than that. These things are no longer available, so it's really important you don't break them. Otherwise, you're going to be looking on eBay for poles. That's usually all you can do. There were a few studies done by some enterprising forum members who's got some that track pretty close, but the originals are the best for the circuit. So I'm going to put the schematic up here. We're going to talk a little bit about what we're going to look at, how we're going to take measurements, and what our next steps are going to be. Okay, this is a schematic of the output stage, but before I get into what we're going to look at first, I want to talk a little bit about troubleshooting in general. Whenever I talk to one of my technician friends and they talk about something they recently fixed that maybe gave them some problems, I always ask basically the same questions. What did you find, and how did you find it? What were your thought processes? What troubleshooting steps did you take? How did you eliminate certain variables to wind up with what the problem actually was? And I think that's really important. It predicates an understanding of what you're working on. So whenever I train new guys at work, I know the ones that are going to be good techs because they all ask some variation of the same question. How does this work? Because you kind of got to know how it works before you can figure out why it isn't. So anyway, here's that bias diode, and you can see it's just a bunch of stacked diodes like you saw before, and it's in series with the bias adjuster, so it's a very important part of the bias circuit. And this thing isn't coming out of protection, so we're going to want to check each one of the outputs here or here, and I'll show you what I find is the easiest place to check these. And we want to make sure that we don't have excessive offset. If there's no excessive offset, then we're going to have to take a look at the protection circuit itself. I did a video on how to troubleshoot amplifiers stuck in protection. And those are pretty much your two variables. It's either a problem in the output stage or a problem in the protection circuit. So we're going to take a look here and see which looks like our problem. So I'm going to want to check an output here or here, here and here, to see if either of these are putting out excessive offset. And then if so, we'll have to see what our next steps are. Okay, so I usually find the easiest way to check if there's any offset at the outputs is just tap off of any one of these emitter resistors, just any one of them in either channel. And I have a clip lead for the negative. We're going to put that to ground. We'll just stick it right there. Try to get the wire out of the way. Okay, I'm going to flip it on with the dim bulb and we'll see what kind of voltages we get. Okay, so first one we look at here. Wow, 16 volts positive. Other channel, 19 volts positive. So it's unlikely we have a problem in both channels. So we probably lost our negative voltage going in here. We're going to want to take a look at that. And for that, I am going to have to take the bottom off. So I'm going to pause this, pull the bottom, and then we'll see what we got. Okay, so I want to check the voltages here, but what I've also discovered is this board here is floating free, and if I accidentally move it, the dim bulb gets very bright. So one of the standoffs is missing. This one's not on. I got to figure out what's going on, but it looks like somebody was into this board. But in any event, let's see what we got here. This should be our positive voltage. And if you can see that, it says positive 39, should be 49, but remember we're on the dim bulb and it's normal to have some kind of loss. And our suspect voltage is perfect, negative 39. So whatever's going on, it is not the voltages coming in here. Now I looked at the front of this schematic, we should have positive and negative 50 coming in. Our negative 51, it says negative 51.5, positive 51.5. I should get a positive 51.5 at 7 and a negative 51.5 at 2. Let's see if I can count these out. 1, 2, 3, 4, 5. 6. This should be our 7. 49. Remember, we're still in the dim bulb. Our negative should be here. And it's negative 38. A little low. And these may be regulated, so I'm going to have to, nope, look at that. Just a bad connection. So I have negative 45 and positive 49. We'll take a look at that, but I also want to get this board stabilized because I don't like that dim bulb coming on really bright. So the troubleshooting continues. All right, so I want to look at these regulated power supplies that feed the front of the schematic. If you look at the schematic of the output stage, you can see we have a positive 51.5 and a negative 51.5. Again, we're on the dim bulb tester, and the voltages are going to be low, but they should be equal. In other words, if we get 45 volts positive, we should get 45 volts negative. Okay, so pin 6 should be right here, and we get about 49 volts. And pin 14 should be our negative. We get negative 40 volts. So we got a bit of an imbalance there. I'm going to want to take a look at this and find out what the problem is. Okay, so I thought there might be something wrong with this negative series pass transistor down here. So I pulled it because I was getting what, negative 40 volts, and I was getting like negative 49, positive 49 here, and like negative 40 here. And it checked okay out of circuit. Maybe I didn't let it discharge long enough, but in any event, I am now getting negative 43. It's a little better, but I don't think it's quite right. So I want to look at the ripple on the output because it seems to be jumping around a lot. And if we look at the positive regulator, you can see it's regulating pretty well. We're down in this drop. It's about 3 millivolts of AC. This is ripple. That's good. But if we look at the negative one, it's all over the place. And I want to get this straightened out because although I don't think it's the root cause of the problem we're having, I have been wrong about this before. And my rule of thumb is if you find something wrong, fix it. You may not think it's your problem, but it may turn out that that's exactly what the problem is. But you can see this is all over the place. All the transistors check out good, but I want to change out the error amplifier, which is this little guy right here. So I'm going to see if I have one of those, change it out, and see if it helps. Okay, so I replaced the series pass transistor, and now if we look at the positive side, we have positive 49. If we look at the negative side, we have negative 49. Now it didn't fix our problem, but it did eliminate one of the variables. And it's kind of unusual because the transistor checked fine out of circuit. It must be breaking down under load. This is not the normal failure mode for series pass transistors like this. And when I say series pass, here's a little shot of the power supply here. And that large transistor in the TO220 package is considered to be the series pass. The transistor that feeds into the base of that is your error amplifier. And we can talk about this a little more in depth, but I want to go back and see if I can find the original problem because both channels are affected, so I wanted to go through the power supply first. There's a possibility, rare though it is, that there's a problem in each channel. So we're going to have to look at this a little more in depth at the output stage and see what's going on. Okay, so after spending too much time poking around after I repaired the regulated supplies, I still figured it had to be the power supply. I was looking at both channels and they both had kind of similar problems, but it is not one of those rare cases where there are just two channels with problems. This is still in the power supply. I neglected when I was checking them, there's two unregulated voltages going in of negative 49.5, positive 49.5, a regulated 51.5 and negative 51.5, and what I neglected to see is there is also a positive 36.5 with no corresponding negative voltage. And when I check that, this is what I get. So we got a problem in the positive 36.5 supply, and I need to look at that. Okay, so I checked the 36.5 volt, and sure enough, it was not there. And I looked at Q5 here, which is the series pass regulator for this. The collector gets its voltage right off the positive 51.5 volt regulated output going through R6 150 ohm resistor. And then there's a voltage divider made up of R7 and R8, and they provide the base voltage, and that gives us our emitter output of 36.5 volts. Now, I pulled Q5 and checked it, it's open all the way around. And that in turn feeds into the front end of the output stage. And the 36.5 volt feeds the emitters of the differential pairs in the front end, also known as the long tail pairs, and also goes down and feeds the offset network. So without that, we had massive positive offset in both channels. Now, I didn't catch this earlier. I was going through the power supplies. The unregulated supplies look good. The regulated positive 51.5 and negative 51.5 did not look right. And sure enough, there was a problem with the negative 51.5 volt, which turned out to be the series pass transistor. But that was not causing our problem. That probably would have manifested itself as excessive hum, maybe not even that bad. I had a Sansui that had something like that, and you only heard it with headphones. But that wasn't the primary problem. The primary problem was I did not check the 36.5 volt. And that was an oversight, simple as that. I point these things out because no matter how long you've been doing this, you could sometimes get ahead of yourself. You can sometimes miss something. I confess I'm not that familiar with this particular brand. Honestly, I don't work on a lot of Pioneers. Somehow Sansuis always seem to come my way. But this has quite a few more voltages. And also there's some that are on the schematic in parentheses that I don't see in this model. So it was just a simple oversight on my part. And once I found that, I replaced the transistor. I don't know if you heard that click, but it just came out of protection. And there's our positive 35 whatever volts. Remember, we're still on the dim bulb. Okay, so I got it hooked up to all the noisy test equipment here. I'm not sure what's going on there, but if we turn this thing on, it's rated at 85 watts a channel, and we're getting 85, 81, 85. There's always a little bit of imbalance. It's completely inaudible. This thing is stock. Nothing's been changed out in it except for the defective parts in the power supply, but it looks like everything's working. I'm gonna have to check it out, make sure the radio works, make sure the phono works, but for the most part, we did the heavy lifting. This thing is now working. Okay, you see that bouncing there? There may still be another power supply problem. However, I don't believe there's any of the supplies that we fixed for the output stage because the output stage looks good. I'm gonna pull the pre-main jumpers out. You see that bouncing went away, so it's something feeding an earlier stage. Could be the tone board, could be somewhere back before there. There's more supplies in here and there may be more problems. Let me just take a quick look before I call this thing fixed and see if we can find out what the problem there is. Okay, so there's a lot of voltages in this thing. I got 5 more I need to check to make sure everything's okay. And I've got this tip on here so I don't slip. We don't have it on the dim bulb, so I want to make sure I don't short anything. So we need to start with 4 and 5. 4 or 5. Okay, I got 13.7. I should have 13.9. So that's good enough. So 11, I should have 28. I've got, and it's dancing around. This may be our problem because these are all supposed to be regulated. Let's see, 13 should be 13.5. A little low, but it doesn't look horrible. And the last one should be 19 volts. That's not looking great either. That's too low. So we're gonna have to look at the rest of these voltages. This power supply seems to have more problems than all the rest of this thing put together. So let's see where we need to go because some of these supplies reference other ones. Okay, so I finally went through and I just replaced most of the capacitors and several transistors in the power supply. There are a couple of 2SC1318s, which are known troublemakers in audio equipment, and in audio stage they will exhibit crackling, hiss, popping, just noise, but in a regulated or voltage regulated circuit they will exhibit the kind of instability we saw. So now that I've gone through the whole supply, now they turn it on and it clicks out of protection. You can see how stable it looks now. However, there is still a problem in here. The tuner worked fine, both AM and FM, but when I go to phono, you can see we got a lot of crap going on there. And it's mostly in the right channel. but some of those same transistors are found in the phono stage. And this got so bad that it actually popped the fuses in my that I have in line with my speakers when I was trying to play some audio through here. So I'm going to go through the phono stage just like I did the power supply. Interestingly, when I went through the power supply, all the capacitors I pulled out, I like to check them just for my own curiosity. The only one that was bad was one that was right next to the heat sink, and it measured just hard, basically open. Anyway, I have a list that I downloaded from the net. You can find it if you look for DLucy, one word, top 10. If you do a search for that, you'll find top 10 transistors, and it's a good list. You'll find that the 1318s are on there, and as I said, I believe there's some in the phono stage. So we're going to have to tackle that next. Okay, so now I've gone through and I've replaced all of the 2SC1313 transistors that were found on the phono board. And when we turn it on now, you can see that everything is stable. We don't have anything jumping around. Both channels look good. And I'm able to pump it up and get signal out of here. So everything in here is happy. So let me just pan down to the unit itself so I can show you what I've been working on. So here's our power supply board. I've got it secured now. And this was the only capacitor that turned out to be bad. You can see the proximity to the heatsink pretty much explains that. I replaced some of these while I was in there. All of these tested within specs. Specs were pretty wide back when these were put in, but they were all okay. However, I had them out, I replaced them. I didn't even bother to replace any on the phono board here. I replaced these two transistors in one channel, these two transistors in the other. You have to be careful with lead orientation because I believe they are different than the 1313s. Fortunately, even though the transistor number is not silkscreen on the board, the orientation is very helpful in cases like this. So I replaced a couple of those in here, 4 of those here. I replaced a few more transistors. The power supply is rock solid. I should have focused here because 999 times out of 1,000, if you have a problem with both channels, it's gonna be your power supply. I got fixated on a diagnosis, and that's always a bad thing. You need to keep an open mind and go, I think this is what it is. But once you start getting sure, you can chase yourself down the wrong rabbit hole. But anyway, I didn't spend too much time on that. Got back to the power supply where the problems were, and probably should have just simply gone down the line and checked them all. However, I did what I did. It's all working now, so all's well that ends well. So anyway, I thank you all for watching. I'm sorry I've been gone for so long. I have a lot of stuff to do. I got rid of a ton of stuff, and I still have a ton of stuff. So it accumulates when you're not looking, maybe when you turn the lights off. In any event, thank you all for watching. And as always, I like giving back to the community that has given me so much. Thanks a lot.